In this chapter, we'll be talking about decimal numbers. Decimal numbers are formed in much the same way that whole numbers were formed. Remember, we talked about whole numbers as being formed with digits, and the digits have value. Let me review that just a little bit. If we're talking about a number like 45, then we say that the 5 is in the ones position and the 4 is in the tens place. And because of that, we have 4 tens, 40, and 5 ones for 45. You see, so whole numbers are formed using digits, and the digits have value. Now, we're just going to continue the idea of digit value in sort of the other direction. When we talked about whole numbers, we were talking about digit value extending in this direction. That is, we had a ones digit, tens digit, hundreds digit, thousands digit, and so on in this direction. Well, now we're just going to pop in a decimal point and create digit value to the right of that decimal point in order to form decimal numbers. Now, you probably know all of this from the past, but it's worthwhile for us to understand the general idea of the formation of decimal numbers. Now, the notion of tenths, hundredths, and thousands that you see written here comes from this idea. If we're talking about ones, tens, hundreds, and thousands, now I'll put a 1 here for the ones digit, a 10 here for the tens digit, a 100 here for the hundreds digit, and 1,000 here. Now, we know that in going in this direction, we're just multiplying by 10 to get the next digit's value. All right, so 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1,000, and so on. Now, think about moving in this direction, because that's what we're going to do in order to go into the digits that describe value for decimals. So from 1,000 to 100, we're dividing by 10. You see, from 100 to 10, we divide 100 by 10 to get 10. Divide 10 by 10 to get 1. So in each case, we're sort of dividing by 10. Now, if we take the ones digit and divide by 10, does it make sense that this is 1/10? Go like this. Yeah, it makes sense. And if we divide 1/10 by 10, then this becomes 1/100th. And divide 1/100th by 10, and this becomes 1,000th. And that's why we have a tenths digit, hundredths digit, thousandths digit. Now, to read a decimal, we read the decimal point using the word and. So to read this number, it would be 47 and 5. Then you read the name for that digit. This digit is in the tenths place. So we say it's 47 and 5 tenths. So the digits to the left of the decimal form a whole number, or that's the whole numbered part of our mixed number, we could say. So it's the whole numbered part over here and the fractional part to the right of the decimal. All right, so it's and is read with the decimal point. So this one is 47 and then 23. 23 what? Well, the name for this goes with the place value or the digit value assigned to that rightmost digit. And this 3 is in the hundredths place. So we read this part as 23 hundredths. So 47 and 23 hundredths. Now in this next one, the 3 is in the thousandths position. So we read the decimal as 47 and 123 thousandths. So we're just reading this number as though it were a whole number, and then we tack on the name of the digit value of the last digit. This one has no whole numbered part, or the whole numbered part is simply 0. So this is certainly a fraction, a part of a number. But it's 5, and the 5 is in the hundredths position, so this is read as simply 5 hundredths. Now notice that when there is no whole numbered part, or the number is describing a value less than 1, that we put a 0 here. And it's kind of it's a convention that we generally use, but it's not a necessity. That is, this could be written as 0.05, but it's a little more appropriate to write it as 0.05. Okay. Now, let's take these mixed numbers and write them as decimals. This is 5 and 7 tenths. 5 and 7 tenths. You know, if we read this and then just interpret it in decimal form, we have our answer. 5, and then the and part that we typically use when we're describing a mixed number. The and part now is interpreted as, or becomes our decimal point. 5 and 7/10. So a 7 is in the tenths place, you see. 5 and 7/10. 23 and 17/100. 23 and 17/100. Now the 7 and the 17 is going to be in the hundredths place. So 17/100. 7 and 3/1000. 7 and, now the 3 is going to be put into the thousandths position, but the thousandths place, the thousandths digit, is the third digit to the right of the decimal point. So the 3 goes here. That means we're going to have to fill these positions with zeros. You see zeros as placeholders for the tenths and hundredths places. So 7 and 3/1000. Let's go the other way. Let's change this into a mixed number. We have 6 and 13/100. Now, if you just read a decimal properly and write it as you understand it as a mixed number, then you'll have no problem with this. 6 and 13/100. 6 and 13/100. 75 and 7/1000. 75 and 7/1000. What about the words and the numbers? How do they sort of play with one another? 6/10. 6/10. A 6 in the tenths place. So we have a decimal, and the 6 is in the tenths place, so we place a 6 here. And typically when we write a number that is less than 1, we put a 0 to the left of the decimal. 20 and. Now when you see the words that describe a decimal and you see and, this is the separator between the whole numbered part and the fractional part. And the and is replaced with the decimal point. So 20 and, so it's 20 and, you see for this part, 13/1000. So the 3 in 13, the last digit to the right, you see in this number, is going to be in the thousandths position. So 13/1000. Gee, for 13/1000, thousandths implies 3 digits to the right of the decimal. 13/1000 means this, and we need to fill this position with a 0. 65 10,000ths. Here is a digit's value, and that digit is to the right of the decimal. We have 65 10,000ths. There's no whole numbered part here, so we're starting with a 0. And now I'd like to identify the 10,000ths digit. Well, let's see. Let's just march to the right here. This is tenths, hundredths, thousandths, 10,000ths. The next one would be 100,000ths and then millions. But at any rate, we want to describe 65 10,000ths. Here's the 10,000ths digit. The 5 in 65 goes in this position. So it's 65, and then these digits are zeros. So here we have 65 in the 10,000ths position for the last digit. 23 and. Oh, I see an and. So to the left of the and would be the whole numbered part, 23. The and is simply the decimal. And now 247 millionths. Millionths. Let's identify the millionths position. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. How many of these rascals do we have? We have 247 of them. 247. And that last digit, the 7, is in the millionths place. And we simply use zeros as placeholders for these other digits. Let's describe this in words. We have 325, 325, and for the decimal point. All right, and what? Now, when we jump over to the decimal part, all we do is describe the number that's over here as though it were a whole number. And then we attach the name of the rightmost digit. You see, the name assigned to the rightmost digit. So we have, just describing this now, without looking at this, just describing this number, this is 30,145. So we would write that down. And 30,000 145, let's come down here. Now, 30,145 what? Well, let's see, we need a digit value for that 5. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So this is 30,145 millionths. Millions. Let's talk about order relationships now involving decimal numbers. We know that 5 can be written in a decimal form as 5 with a decimal here. In fact, all of the whole numbers we've ever talked about contain implied decimals. It's just that the decimal lies to the right of the rightmost digit in a whole number. All right, so 5 is the same as 5 with a decimal, or it could be described as 5 and no tenths, or it could be described as 5 and no hundredths. You see, like this. All of these have the same value, so all of these are equal to one another. And in fact, 7 and 3/10 is the same as 7 and 30 hundredths. Now, it seems to imply here that when we're talking about decimals and the digits that lie to the right of the decimal point, that we can, without changing value, add a 0, just tack on zeros sort of at the right end of our numbers and not change the value. Now, that sometimes is helpful for us to see some order relationships, and I'll show you why in just a minute. Now, if we're deciding on an order relationship between these two numbers, you see, we have 4 as the whole numbered part here, 4 is the whole numbered part here. So if we're just comparing 4s, it looks like they're equal. But we have to compare the tenths as well. Here we have 8/10 involved and 3/10 involved here. So 4 and 8/10 is certainly greater than 4 and 3/10. So we would write greater than for our order relationship. Now, in these two numbers, we have 5 for the whole numbered part of both of them. And this one is 6/10 and this one is 295 thousandths. Well, which number is larger? Well, it turns out that in order to see that relationship, we can actually see it in a couple of ways. One way is to write these both in terms of the same digit value. That is, I can tack on some zeros here, you see, and make this 600 thousandths, and this is 295 thousandths. Well, 600 thousandths would be larger than 295 thousandths, so it turns out that this number is greater than that number. Now, another way to proceed here is to simply kind of look at the digits from left to right in the two numbers. And when the digits differ, that's when we really pay attention to the situation. See, looking left to right, the 5s are the same. And then we encounter a decimal point. All right? Then we encounter the tenths. And all we need to do is really focus on the number of tenths we have here and the number of tenths we have here. They're different from one another. We have more of the tenths here than we have over here. And the other digits really don't make any difference. You see, even though this 9 is a digit which is larger than the 6, it has value. And it's in a position which has much less digit value, you see, than the tenths digit. So 6/10 outweighs the 2/10, and therefore this number is greater than that one. All right, let's go on that basis with this next one. We have, let's see, no whole numbered part for both of them, and the first digit from left to right that is different in the two numbers would be this one. So all we have to do is look at those two. And it turns out that 0 is less than 1, or no tenths is less than 1/10, and therefore this number is less than that one. Now another way to see it is to write the same number of digits to the right of the decimal here as we have over here. And I can do that by just tacking on zeros. I'll tack on a 0 here, and now I have, let's see, 390 tenths, hundredths, thousandths, 10,000. 390 10,000ths, and this is 1,001 10,000ths. And therefore this number, once again, is larger than this one, or we say this one is less than that one. Rounding decimal numbers is handled in much the same way as rounding whole numbers. Let's review the process of rounding whole numbers and then we'll jump into decimals. Suppose we want to round 4,735 to the nearest 10. Now remember, in that process we identify the tens digit and we look at the digit just to the right of the tens digit. So we identify the tens digit, we look at the digit just to the right. It is 5 or larger than 5, and therefore we're going to make the tens digit 1 larger, and we're going to change the 5 into a 0. You see, we exchange this for a 0, we make that 1 bigger. So this is 4,740 to the nearest 10. To the nearest 100, we look at the hundreds digit. Now let's see, let me erase here, and we're looking at the, here's the hundreds digit, we look at the digit just to the right. You see, it is smaller than 5, and therefore we're just going to kind of lop it off. And really what we're doing, we're not just lopping it off, we're changing it into a 0, and that into a 0 as well. So this is 4,700 to the nearest 100. To the nearest 1,000. Well, if we're rounding to the thousands digit, we identify the thousands digit and we look at the digit right next to it. We look at the neighbor, and this neighbor is 5 or bigger, you see, and therefore we're going to make that thousands digit 1 larger and change all of these into zeros. So to the nearest 1,000, this is 5,000. Now, we approach decimals in much the same way, except instead of changing the digits to the right into zeros, we can just lop them off altogether. That's what we do. We just eradicate them. So when we round this number to the nearest 10th, we look at the 10th digit, we identify the 10th digit, and we look at the digit just to the right. All right, now, since this digit is 5 or larger, we're going to change the 10th digit into 1 larger. That is, we're going to make it 1 larger. It's going to be 4 tenths. So this is going to be 5 and 4 tenths. And notice that once we change this into 4 tenths, we just lop all of these off. Instead of making them zeros, you see, we just lop them off like this. All right. Now, hundredth, to the nearest hundredth. Well, let's see. Let me start again. To the nearest hundredth, here's the hundredth digit, and we look at the digit just to the right of the hundredth digit. It happens to be 5 or larger, and so we're going to make this digit 1 bigger. Well, when we make 9 1 bigger, it becomes 10, and the 1 in the 10, we have to carry it over here to the 3, and that 1 with the 3 becomes a 4. So this becomes 5.40. 5 and 40 hundredths to the nearest hundredth. Now, we keep the 0 here. We want to write the 0 because it implies a degree of accuracy when we're rounding to the nearest hundredth. And this kind of situation occurs, we want to keep that 0 to identify the position to which we have rounded. So this is 5 and 40 hundredths. To the nearest thousandth, well, we go back up here, we identify the thousandths digit, that's this digit. We look at the neighbor to the right, it is smaller than 5, so we're just going to lop it off, and to the nearest thousandth, this is 5 and 397 thousandths. Sometimes we even round off to the nearest whole number. Now the whole number part is the number to the left of the decimal. The nearest whole number, you see, we look at the digit to the right, it's a 3. We lop it off because it's smaller than 5, and so this number is 5 to the nearest whole number. Consider this problem. It says, on average, an American goes to the movies 4 and 56 hundredths times per year. To the nearest whole number, how many times does an American go to the movies? See, a lot of times when averages are used, it's it's a little confusing, or the usefulness of an average like this comes into question. We don't want to know exactly the average. We don't need this degree of accuracy. We want to know whether it's 1 time a year or 10 times a year. You know, we want that kind of reference. So we want to round this off then to the nearest whole number. Okay, let's do that. So let's see. To the nearest whole number, what is that number? Well, let's see. The whole numbered part is to the left of the decimal. So the nearest whole number would be found by looking at the digit to the right. It is 5 or larger, so we make this one bigger. And so on average, an American goes to the movies 5 times, or witnesses 5 movies per year. By the way, this idea of 4 and 56/100ths doesn't mean that everybody in the United States goes to 4 whole movies and walks out of one, walks out about midway through one movie. It just means that this is the average for all people. Some people go 4 times, some 5, some 10, some whatever, but on average they go 4 and 56/100ths times.